This is the same case with Fabs. He is, as all the other great presenters, a beautiful, amazing, intelligent person. And please, an applause to Fabs while he joins me on stage. Woo, yeah!
Hi.
Fabs.
Yeah, so basically I'm going to be ranting a bit about vulnerabilities in open source software and the disclosure process behind them. I'm sorry about the rant, and I'm sorry about my slides. They just came into existence like half an hour ago. So I'll do my best, but I'm sorry for that. So the title of my talk is Grepping for Shells, because most of the stuff I did I found on with grep. It's an awesome tool. Love grep. It's the best, seriously. And apart from that, I'm going to talk about like how the whole responsible disclosure thing works sometimes, especially how that works in open source software and what can go wrong. The software I'm going to talk about as an example here is one I found a bug in. Was my first disclosure. So I don't really know how the whole thing works, but I'm kind of doing a bit of storytelling. And the software is used by this kind of weird research lab in Switzerland that does like these shooting little bits at each other. And it's the software that I use to look at the data they're using and how to analyze it and so on. And the story starts sometime around Easter when I had a bit of time. And first of all, what's root? It's the software I'll talk about. There was a talk about it on the last C3. Something about LHC plus Higgs plus something is equal to something. It was a good talk. Recommend watching it. But yeah, this is more about the bugs in it. So root, this is the text they use to describe it on their website, where they say it's a framework to look at things and to do things. And but most of all, the thing I found it to be is very specialized software to do special use cases. First of all, you can save data in files. That's very special. That data is in tables. And tables are called trees in root. I don't know why, but they are. Columns are called branches. And in those columns, you can have rows or cells, and you get the idea. And they're called leaves, not tea leaves. But everything in root starts with a T because it's a type. It's C++. I don't know. And of course, when you have like software that does this kind of stuff, you need an embedded scripting language. So what they did is they put this embedded scripting language in there. It's called C++. And it's interpreted by a Clang thing that was made into a just-in-time compiler called Cling, because it's interactive now. And they do like big data, like they have a lot of these collisions, so there's a lot of things happening, and they need to save it, and it's like, a lot. So they need to save that stuff, they need to process it. So there are a few requirements. You need to not have the whole file in memory at one time, because that can be a few terabytes, and that's annoying. Then you have to be able to do like some sort of cluster operations, so they have their own daemon for that. And because you need to like access files over the network, they decided to do this thing called implementing their own file server, and you can open files remotely, and the protocol is called root. And it's an awesome file server. You can open files and so on, but I'll come out to that. So there's a few services it offers, and some of that is a remote code execution, and some of it is local code execution as a services. And this will be 3 acts because it's a trilogy, First of all, when I looked through the documentation, can you read this? Is it too small? Yeah, it is. But anyways, there's this documentation thing that they have, and it says that you can open files, and when it starts with root, then it's open over the network, over this network server, which I thought like, cool, let's take a look at that. So yeah, that's a thing. It's the service that forwards, open, read, write, and so on over the network. And you can open files, and you can, every time you read something, it reads a whole block and sends it to you. It's great, really. The service is called rootd. I don't know. On some distributions, it runs as like root, but that's not because it's in the name. Sometimes it doesn't run as root. And it's deprecated, but still used. So. And the new thing is called xrootd. I don't know, it's because it's better. So rootd, they thought it's really good to produce shell variables in file names. And they thought of how do we do that? So turns out they do it like that. Does anyone see what's wrong with this? Yep, basically, yeah. And then they decided to fix that by escaping stuff. So this is basically the stuff they are doing. And yeah, they're putting echo in front of it. On HPUX, they put bin echo in front of it. And they even do like this thing where they escape shell characters to fix that whole thing. So these are the characters they escaped. I don't know why they didn't think of backticks, but yeah. So there was a remote code execution in that. So then they decided, okay, this whole thing is deprecated anyways. So I looked at the new one because they're not going to do the same mistake twice, right? So no, they didn't. But I was having fun and I was using grep to do things. So I started grepping source codes for Git repositories for popen. Popen's awesome. It opens a shell and gives you what the shell does. So sometimes they do that. So they decided, xrootd is cool. It's more web scale. You can even authenticate with a lot of users. So they put this LDAP module in it, and they needed to map users to the LDAP principle, distinguish names, and grepping for popen finds things. Anyone see what's wrong here? It's the same thing as before, pretty much. You can basically just, this thing here is the username that you could put in to do it. The other bug was you didn't have to put in your username. You had to authenticate first and then put the file name. But here you can just put in your username that contains quotes and a semicolon, and there you go, you have a shell. There's another bug there as well, where you can put in a long username. It also works. Yeah, and it's all fed into popen. Oh, okay, yeah. So episode 6. Those were the 2 remote code executions I found. The next one was actually in the documentation, so it's actually also worth grepping documentation for C++ keywords. If you have C++ things. So the way they represent a function object, it's in their scripting language, is you have this thing called a TF1. It's T for type, because it's a type, F for function, and 1 for one-dimensional, because it's C++, And that can be a lot of things. It can be an expression, it can be an expression, it can be a lambda expression. So if you grab stuff for lambda, sometimes you find things. And the way you use it is you create a new type of this object, and in a string, you put the C++ code you want to execute. And the cool thing is you can save these things in those root files. You can save those in those trees or branches or next to them, or in histograms that you make. So does anyone know those Office macro things? That when you click execute when you open an Office thing from one of those weird emails that want to send you money. Yeah, basically same thing. Because you can put lambda expressions in there. It's even documented. It's as a service, So you can actually put create functions that look like that. It's cool. And So, you start grepping documentation for like, you know, shells. You start grepping like source code for shells, and you find things. And then the next question is, what do you do? I mean, this is like software that's running on like universities and like research institutes, and it's not. You kind of have some sort of responsibility if you feel like that, and you want to make sure this gets fixed the right way. TM, whatever that is. But you want to make sure this gets fixed without too many people like taking advantage of it. So how do you do that? It's surprisingly difficult actually, and takes a lot of time. So I started looking around, and I found like there's this GitHub repository, and there's like a URL up there. So I clicked that. There's this page, and it says, hey, there's a public key, so that you can like contact us with if you want to like disclose something. I was like, yay, they get it. Cool. By the way, I'm going to show you some emails. I'll only show you emails I wrote, or emails that were not encrypted, which are public therefore anyways. So I sent to them this message, which roughly descripts to like this. I don't really know how this disclosure process works, so it said like, hey, I have discovered something there. Those are the things I found. I have some proof of concept stuff, and I'd like to like disclose it. And how do I do this? And here's my public key. Feel free to contact me with it. They sent me this email back, which is also encrypted with this weird cipher called HTML. I redacted the name, but it's this person from like that organization. I'll call him like the CERN search guy or something like that. Yeah, and that roughly decrypts to that. Oh no, wait, did I? No, I don't have this decrypted. But yeah, it basically says like, yeah, thanks for contacting us. If you have a proof of concept, we'd like that, and like tell us how to do it so we can fix the software and arrange for like it to be rolled out. And I was like, yeah, cool. This was like a few minutes later, and I was like, on like an Easter day where people are usually like not at work in the evening. So, yay, they get it. Even though it wasn't like encrypted. But yeah, so I sent them this back, and I said like, yeah, I couldn't read your email, but maybe send me text plain messages with like with like PGP. That's cool. But yeah, so that's that. And I gave them some like proof of concepts how to like open it. And I suggested a few more things. I don't know if it was my place to do this, because I don't know how to do this, but I thought it would be like a good idea to, suggest being kept in the loop, or to like ask them to like publish stuff that like a security advisory or something like that, so people know to actually fix their stuff and get patched. Because fixing software doesn't help if people don't patch it. Yeah, I got this thing back, which roughly decrypts to that, which is some ticket system saying, yeah, we're at it. The fix turns out to be like for the macro thing, where you like can open a file and it executes code. It seems to be kind of difficult because executing code is the purpose. So it's code execution as a service. Yay. And, you shouldn't trust those files. But, yeah, anyways. And that's pretty much the last thing I heard. Then, a while later, I updated my, Git pulls and so on, and saw they fixed it. There is this pull request, and it got merged, and it was cool. That says, yeah, addressed security threat reported by, and the reported by, I redacted the name, you can't see it, but that was that search guy that I reported the thing to. So, yay for attribution. But the good thing is the software got fixed, right? And yeah, it says here someone even like suggests, could someone merge this in? Maybe we should backport it. As in put it into like an old software. Which is cool, yay! Except it didn't happen, it just got merged. And the other software, the XRoot, someone said, yeah, that may become a security threat, so let's not build this LDAP module thing anymore. So it's like, that's cool. At least, you know, no vulns in the code they like ship now. It's like all commented out. So yeah, sorry, that's the end. It's fixed. Really? So yeah, not really. So the thing is, getting it fixed is like the beginning of it all, and it seems disclosure is like a really like difficult process, and doing it takes time and effort. So it turns out this is like a screenshot from archive.org. Awesome project, they're great, really, they're great. And it's right, like the latest release is at the time where the fix was pushed, and like the latest release like was like around then, and like version 60904 was the one they committed the fix in, and version 60902 was the one that was the current development branch, or like unstable or something like that. This was stable. People use stable. People like stable software. They don't like their bugs getting fixed. So, and this was like, you know, the old version, the really stable one, you know? And I think, yeah, so stuff like that happened. And it, you know, there's these things called changelogs. People don't put things in them that might look bad for them. So that's also great. So, no, you know, the bug was fixed, but no one knew about it, and no one was going to patch their shit. So, yeah, the other thing, XRoot did put it in the changelog. They said, do not build package lib xrd sec gsi gmap ldap.so. Would you like update your software if it says that? Would you feel like you had like a bug? Like, you know, remote code execution kind of in the username kind of bug? Not really, right? So yeah, I thought, you know, there's one way to make sure that people get the idea to like patch their stuff. If they're not gonna do it, you know, I'll have to. So there's this awesome project called the Distributed Weakness Filing Project. It's kind of starting out. Till now, every time you want a CVE, it goes through some like numbering authority that assigns you a number. And once you get that number and it gets verified, then that gets pushed out to like all the distributions and like loads of people who, you know, see that there is a problem. That's the point of doing these. And sometime in May, June, unfortunately don't really remember anymore when that was exactly. I filled out this Google Docs form, which is the how to get a CVE for open source software. It seems like this is the only project that currently assigns CVE numbers for open source software. That took ages. Oops, that's the wrong slide. Then I spent a lot of time waiting. In June, I pretty like, I think it was a month later or something like that. I'm not quite sure, to be honest. I got an email to accept some terms of use or like contributor guidelines that I'm willing to like publish stuff. Then nothing happened. Then mid of August, I got a notification of assignment that my CVEs got assigned. And sometime in November, I got an email like, here, there's a CVE. Can you like, I have no idea, you know, what the problem is, because there is like nothing in the release notes. There's nothing by the project itself referring to the problem. So yeah, I had to clear that up. And then like they were assigned, so which is cool. And then even later, it got even better. I just saw this like 2 hours ago. It's 14 days ago, which is approximately the time those CVE numbers hit the bug trackers. They actually backported the fix. So yay for them. So it seems like the way to get stuff done is actually to get these weird CVE numbers. Otherwise, people don't care. And it even like, that was the slide I was trying to show you here, it even landed in like these Debian trackers, which is cool. They decided not to fix it because it's, authenticated code execution, and I think the package itself is not supported anymore because no one maintains it. But yeah, that's cool that there is like things and trackers about it. And so yeah, I have like, that is till now where I'm at. I don't know if there's still something happening or anything. But the first, like, I have a few takeaways from it and things I learned throughout the process. It's responsible disclosure is really, really hard. Like, it's a lot of work. It's not easy. You have to kick people, and people will not really want you to do that. Some people will, but people don't really want their bugs to be like public or whatever. Like one takeaway for like people who are actually in the business of like, mitigating exploits and or like the whole communication stuff. The work doesn't end after the bug fix. Arranging for a bug fix isn't the end of it. That bug fix still even has to like land in repositories. That bug fix has to land in like the stable branches. It's always nice to credit people who found it and not like, take the credit yourself. And things like the distributed weakness filing project, they're awesome. They're very necessary, and they cause things to like work, and without them things don't work, because without them bugs don't get pushed, like the fixes don't get pushed to like out there. And especially like in non-IT and scientific communities, like for example where you get root, software engineering is difficult for people who don't do it, and people who don't do it end up not being educated to do it. And so it really helps to like have some kind of synergy between people who are in software engineering and in security and other areas, which is, I feel, a bit missing. And people shouldn't have to make their own tools if their like work isn't really making them but using them. And yeah, that's like where I'm at. I'd like to thank the Distributed Weakness Filing project for taking care of like bugs and doing the stuff they do. They're awesome. I'd like to thank CERT for getting the bug fixed. The root project for doing that, making that software, because it's actually useful. My CTF team Tasteless, they're great. The best. Totally, it's true. And that very awesome person who made me look at root. Are there any questions?
Thank you. Fabs, thank you very much. Any questions from the audience? I can ask a few questions to warm you up. Fabs, you promised. Okay, now I'm first though. You promised me a talk. If these guys wouldn't have done the backport 14 days ago, would you have held the talk here anyway?
To be honest, I saw that the backport happened like 2 hours ago, and I don't know. I think publicity is one way to get stuff fixed. And if the bug is like the moment the fix landed in like a pull request, it's kind of public. People know it. People look at the GitHub pull requests for like the fixed remote code execution. Please merge. Yeah, those things are out there, and there's a process to like fix code and then publish that there is like a fix out there and please update your stuff. And if that isn't followed, but you fix it in like master, but you don't fix it in like your stable branch, then I don't know what to do about that.
Well, I don't really see a big difference between code as a service and remote code execution, so why would anyone do this at all?
Sorry?
I don't really see a big difference between code as a service and remote code execution. Why does this package exist at all?
Well, it's basically something that works like a database, and it has functions to analyze data. It exists because people are too lazy to look at the new things and want to use their old stuff that used to work in the 80s. So it's legacy, but it's the best there is for the stuff it does, which is have a lot of classes that do a lot of data analysis and scriptable in C++.
Any more questions? So Fabs, one last question from my side. I will sit down too. This is the cameraman has awesome fun. Normally you stay in one height. You don't move down. Like the back is like there was a lot of movement.
Sorry.
Fabs, this was a very interesting talk. And if any one of us would like to talk to you about it, how would we do it? How would we get in touch? Maybe questioning?
I don't know. If you see me walking around, I'm mostly walking around, so I don't really have a place I'm sitting here at the moment. So there isn't really that much. You can dig out my email from the CVE number that was on the screen, which, yeah, something like that.
Service as a service.
Yeah, basically.
Okay. Then this concludes the talk held by Fabs. Last applause, please.